Hey everyone, welcome to day 9 of our derivatives and integrals challenge. So for the first one, we're going to differentiate this t equals some function in x. So let's go ahead and do that. Nothing too crazy today. So we'll have 20 over 5, that's going to be a constant. The derivative is going to be 0. So all we'll have for the derivative of negative x over 5 is negative 1/5. And then here, we're going to have, I'm going to leave the over 3 as a 1/3 in front. And then I'll do the square root of that is the same as an exponent of 1/2. So I'll do times 1/2 the square root of x squared plus 144. Or rather, that's 1 over that. I was going to do to the power negative 1/2 times 1 over the square root of x squared plus 144 times, by the chain rule, times the derivative of the stuff underneath the square root. That is the derivative of x squared plus 144, that's 2x. And so that means that, t prime rather, is going to be negative 1/5 minus 1/6. The 2's can cancel out, so we'll have minus x on top over 3 times the square root of x squared plus 144, and that is as simple as we will have it. You can also write it as dt dx if you'd like. Okay, just giving you some options with your notation. Now the integral is going to be a bit more interesting. We have the integral of sine squared x dx. Right now, you know that you can't simply raise the exponent by 1 and then divide by that new exponent, right? Because we have the chain rule, right? The antiderivative of sine x is negative cos x. That's going to get messy. So what we have to do is use one of our trig identities you likely learn in one of your pre-calculus classes. And I'll remind you that there is an identity that says that cos 2x is 1 minus 2 sine squared x. And that means that we can do some algebra to isolate that equation for sine squared x, right? That means that well, let's do it step by step. Cos 2x minus 1 is equal to negative 2 sine squared x. And then dividing both sides by negative 2 means that we get 1 minus cos 2x all over positive 2 is equal to sine squared x. And now that, one of our double angle identities, that allows us to make a substitution in for sine squared x inside of our integral. And so that means that we get to rewrite this integral as the integral of 1 minus cos 2x over 2 dx, right? Now that 1 over 2 factor we can plop outside of the integral. And so I have the integral of 1 minus cos 2x dx, right? And now we can just go ahead and integrate that, right? That's 1 over 2 times the integral of 1, antiderivative of 1 rather, is x. And then the integral of cos 2x is going to be 1/2 sine 2x, right? So we'll have minus sine 2x over 2, let's say, because, right, if we differentiated this, we'd change the sine to cos, and then we'd multiply by the derivative of the 2x, which is 2, and the 2 would get rid of the 2 in the bottom to give us back the cos 2x, right? Thinking in reverse. And so that means that we get this, and then we would add a constant integration at the end for good measure, plus c. And so to kind of simplify that out, we'll have 1/2 x minus sine of 2x all over 4 plus c. And that is our final answer. So when we start integrating these trig expressions, we oftentimes have to make use of our trig identities to kind of dwindle it down to something that we can actually integrate manually. So hope this helps. Thanks always for watching, and please leave a comment below if you have good questions. Take care.